So for this problem, we're finding, this video, we're finding possible rational zeros. So we don't need to find the exact values. What we're trying to do is look at a polynomial like this one and tell what are possible rational zeros for the polynomial. So we're going to start with one that we can actually see. This one. So we know our zeros here would be x equals -3, 3/2, and -5. And remember, solving this to find the 3/2, it's 2x minus 3 equals 0. And then you, oops, I completely forgot to subtract. So it's 2x equals 3, and then you divide by 2 and divide by 2. So if you notice, it's just the 3 divided by 2. That's what's giving us these zeros. So if we were to multiply this out now, our first term would be x times 2x times x. So it would give us 4x cubed. And if we were to multiply the last one, that would be 3 times -3 times 5, which would give us -45. And then in the middle is just the multiplication of all those different things. But the first multiplied give us the first, the last multiplied give us the last. And then by multiplying all this out using FOIL, we would get all that middle stuff, which doesn't matter. Because, see, what we did here is we used the x, the 2x, and the x, the parts of our zeros, to make the first term, and the 3 and the -3 and the 5, the other part of our zeros, to make this one. So if you take that last number, -45, and you divide it by 4, just like we did with 2x minus 3, we're just solving it kind of, like one gigantic solver. This right here is what will give us our zeros. It's all the factors of the top and the bottom. So to make 45, you would have -1. We're going to put plus or minus on this. You would have 1, you'd have 3, you'd have 5, you'd have 9, we'd have 15, we'd have 45. All the different factors that we have. 4, we'd have 1, 2, and 4. And so this right here are all of the possible zeros for the polynomial that this would create by multiplying. I mean, obviously we already know what they are. And so if you check it, you can see that we have -3, it's right there. We have 3/2, see, it's right there. And we have 5, it's right there. So if you know the first term and the last term, that's going to give you all of the possible zeros. The last create the last, and the first create the first. So writing them as a fraction, last over first, gives us all of our possible zeros. So our last number here is 8. Don't worry about the sign. What are the factors of 8? And so I like to just start writing. 1, is 1 a factor? Yes. Is 2 a factor? Yes. Is 3 a factor? No. So don't write it. Is 4? Yes. 5, no. 6, no. 7, no. 8, yes. And that's it. You can't go past 8. The first number is 2, and so obviously 1 is a factor, and then 2. So our possible rational zeros would be plus or minus, and you just write them, just like this. I mean, listing them is going to take you a long time. So we just write this, and then what this represents is all of the different numbers. So we'd have plus or minus, positive or negative, 1, 2, 4, 8, or 1/2, 2/2, which is 1, 4/2, which is 2, and 8/2, which is 4. So if you were to actually write them, it'd be 1, 2, 4, 8. And then 1/1, which is 1, already got it. 2/1, which is 2. 4/1, which is 4. 8/1 is 8, already got it. And then we move on to the 2, so that's 1/2, see? That's another one. And then 2/2 is 1. 4/2 is 2, and 8/2. So these are all of the possible ones, obviously positive or negative. So these are the possible zeros. And so why do we need these? I mean, it's a nice old trick. We have calculators now that will find zeros for us. So this method isn't done. But let's just say you want to do it by hand. You now have a way to narrow it down. So if you want to find one of the zeros here, you know to start with a 1/2. And then a 1. In fact, I wouldn't even start with a 1/2. I would go straight to the 1. If 1 doesn't work, you try -1. If that doesn't work, you try 2, and then -2, and then 4, and then -4, and then 8. You're going to hit one of the zeros. And once you hit one of those zeros, you can then convert this to a quadratic and find the rest of the zeros. So this is just a technique to narrow down the possible zeros. But all it is the factors of the last over the factors of the first and any fraction that it creates. So like here, it would be 1, 3, 5, 9, 15, 45, or 1 half, 3 halves, 5 halves, 9 halves, 15 halves, 45 halves, or 1 fourth, 3 fourths, 5 fourths, 9 fourths, 15 fourths, and 45 fourths, plus or minus. But that would be all the possible zeros. Doesn't mean they are. These are just possible. Thank you.